Saturn has a lot of moons, and we don't have time to go over all of them. So I'm saving kind of the best for last to talk about, and that's Titan. Titan is actually huge. As you would expect from the name Titan, it is very large. In mythology, the Titans were the offspring of Saturn, so yeah, it made sense that a moon of Saturn be called Titan. When I was a kid, most books said Titan was the biggest moon in the solar system. It's not. Ganymede's biggest. So why do they say Titan was biggest? Well, because if you measure Titan from one side to the other like that, then you get a bigger number than if you measure across Ganymede. Now, what we don't see here, though, is that Titan has an atmosphere. So the actual surface of Titan is actually down inside there somewhere. And so if you measure from cloud top to cloud top, you get a bigger number. If you measure just the solid part, you get a smaller number. And in the early years, when you tried to make these measurements, there was no way of measuring how thick the atmosphere was or how high the clouds were. And so the assumption was that when they didn't really think it would be totally covered in clouds, so they thought they were actually measuring the size of it. Then they realized there's clouds there, and they thought the clouds would be low altitude because they couldn't imagine a very thick atmosphere, a very deep atmosphere. On the right here is actually kind of a back view of Titan seen by one of the spacecraft, looking at it, looking back at it, and see the sun shining around here and refracting in the atmosphere. Titan is the biggest moon. It is way bigger than our moon. Titan, like Ganymede, is between Mercury and Mars in size. If you strip away the clouds, then Titan would look something kind of like it does in this picture right there. But again, generally you have those clouds around it. The clouds are mostly made of methane, and that blocks our view of what comes below. Well, methane reflects light at certain wavelengths, and so if you filter out that, then you can sort of figure out what's going on below. And so that's how you get images like that. The atmosphere of Titan is about 1.5 Earth atmospheres, 1.45. Now, that's actually a little thicker than Earth's atmosphere, a little more pressure, and that's because it's so cold here. Often you get higher pressure when it's cold because the atmosphere is more compacted. But that's not an unreasonable pressure. That pressure is about the pressure you get about 12 or 15 feet underwater. And so that's really a very reasonable, livable atmospheric pressure. The atmosphere is mostly nitrogen, over 98% nitrogen. Earth's atmosphere is mostly nitrogen, so the atmosphere of Titan is something we're familiar with. It's nitrogen. It does not have oxygen in it. About 1.6% of the atmosphere is methane. So it's nitrogen, and most of the rest of it is methane. Methane, CH4, chemically. This is the main component of natural gas, methane. But we also have in the atmosphere propane, acetylene, ethane, methylacetylene, and hydrogen cyanide. These are all hydrocarbons. Methane, CH4. All the rest of these are mixtures of carbon and hydrogen and so forth. And so these hydrocarbons make it a very interesting atmosphere. You know, I can make a joke and say this is kind of like the atmosphere around Houston. Okay, but all these sort of things here are in the atmosphere. There's no oxygen, so it's not going to burn, but you have all these organic molecules. Now, the temperature and pressure on Titan is near the triple point of methane. Now, let me explain that. Triple point in chemistry is the temperature and pressure combination that allows solid, liquid, and gas to coexist. The temperature and pressure of Earth's atmosphere is very close to the triple point of water. That means solid, liquid, and gas, water can all exist. Slight changes in temperature and pressure on Earth makes the water go from liquid to gas, or liquid to solid, or gas to liquid, or gas to solid. This is how we get rain, snow, evaporation, sublimation, all these different effects that happen in weather. That's because it's very close to the triple point of water in Earth's atmosphere. Titan is very close to the triple point of methane. So that means methane can exist as a solid, or as a liquid, or as a gas. Now, that's very much like water on Earth. In fact, the clouds, some of the clouds of course, obviously it's a methane atmosphere, so the gas in the atmosphere, but some of the clouds are droplets of methane, and they can collect together and fall as rain. Some of the clouds are like methane ice crystals, so like cirrus clouds on Earth. So you can actually get perhaps methane snow on Titan. It's going to collect and run together. In fact, the Hubble Space Telescope, when it looked at the wavelengths that methane tends to reflect, found large bright regions on Titan, suggesting there might be like seas or oceans of methane, so or giant lakes or something. So the liquid methane running together like in rivers and forming lakes, evaporating, going back into the atmosphere, and then raining again. So in other words, methane does what water does on Earth. So this is going to be a very interesting sort of world. So the weather picture is going to be very, very similar here to what it is on Earth. And so, except it's going to be much, much colder. On Earth, liquefied natural gas, that's going to be liquid methane on Earth. It's very low temperatures. Well, there's very low temperatures on Titan. This is a very long ways from the sun. And so we kind of expect that it's going to be different. In fact, at the distance that Titan is from the sun, water is always perpetually frozen solid. So that means that you don't get liquid water, you get ice. And then on Titan, however, you can get other sort of things. You can get clouds and evaporation and rain from methane. The Cassini spacecraft was launched to study the planet Saturn. This was the only spacecraft that was ever designed to orbit Saturn. The Pioneers and the Voyagers flew past Saturn and took pictures. One Pioneer passed Saturn, and the two Voyagers flew by Saturn and took pictures as they went by, but only one spacecraft was ever designed to orbit it, and that's the Cassini spacecraft. And so the Cassini spacecraft was launched, and it has radiothermal generators like everything else in the outer solar system, antenna, magnetometer, instruments here. You got to measure plasma and the space weather in the vicinity, and it also had cameras. But it very importantly had a probe that was designed to detach from the mother craft. Instead of going into the atmosphere of the planet like the detachable probe did with the Galileo spacecraft when it went to study Jupiter, this probe detached to land on Titan, the very first and so far only probe to a moon of another world. Well, I say that because the Russians had sent the Phobos spacecraft that was going to study Mars and the moon Phobos, but they did not operate properly. One died on the way there. One quit working just as it started to approach Phobos. But this will be the only time that you have a successful study of the moon of another world. Cassini spacecraft had to get to Saturn. That's a long ways away. It's a very big spacecraft. And so we did not really have a rocket big enough to send it out there directly. In fact, we didn't have a rocket big enough to send it even to Jupiter. So what we did was we launched it to Venus. Well, you say that's going the wrong way. Well, we launched it to Venus and let Venus's gravity toss it back outwards. And so Venus's gravity tossed it out, and then it made an orbital maneuver, dived in back towards Venus again. Venus's gravity tossed it out further. It flew past Earth, and Earth's gravity then tossed it out even further. So this is a very complicated multiple slingshot type thing. Earth's gravity then tossed it to Jupiter. Jupiter's gravity tossed it on to Saturn, so that it arrived 2004. It launched in 1997, arrived 2004, so 7 years later. And that began the study here of the planet Saturn. Not just the planet Saturn, but also the moon Titan. And so up close, it got the very best view here. And so this is actually a Hubble telescope view of map of Titan with that little oval showing where that lander was going to land, right on the edge of one of those dark regions right there. Up close, the Titan viewed from Cassini, able to look through the clouds a bit, and you can see those big lakes. Again, you can call them lakes or oceans. This is a small world, so a small ocean maybe, or a big lake. And again, we see evidence of rivers, tributaries, so evidence of rain, not water rain, methane rain, running down into these large dark regions. Evidence of mountains, suggesting the ground underneath is shifting and moving, pushing up mountains. This is not volcanic mountains, but these are other kinds of mountains here. And so, again, this is a geological